Hey guys, welcome to the channel. Today's video we're going to be putting a washing machine direct drive stator onto this water wheel and see just how it does. We're going to basically rewire the stator to be a 4 little motors inside, so 9 coils to per group, and we'll show you how the difference is of the speed of that water wheel right now, and then after I hook it up to the generator, we'll show you the pros and cons of what we're doing. Let's get started. Hey guys, this video today we're going to show you how to wire this washing machine motor, or a washing machine stator, up to be, this is a 36, and we're going to wire it up to be 4 groups of 9, so 9 coils per group, which will bring our voltages down but our amperage and wattage up. And we're going to be hooking this up to a water wheel, so we want to create power. So let's get on with it. All right, we got 2 stators we're going to build. We're going to build the mount system for it right now. So I put this on this piece of wood. I'm going to double this up so it's going to be 1 inch thick. Might change that later to be metal or a plastic cutting board to hold it all together. Not sure yet. But anyway, this is our stator. It's a 36, Samsung 36. I got laid on this board. I outlined the outside of this to mark out the outside diameter, and then I counted out half and then quartered it, and I took a ruler from those marks and found the exact middle of this. So now we're going to take it, we're going to cut this board off at 18 inches. So we have 2 pieces 18 inches long, and then I'll put them together, drill out the center hole, and screw them together so they're solid, and then we'll start our process of putting the rod through the middle and all that. All right, so we got the first link set up for you here. So I took the end of this first wrap, put them all together, put a beanie on them. Here's my number 1 here for the next round of 9. So basically I took X-Acto knife and scraped the, if you can see it, scraped the sheath. So it's that little fake sheath of copper looking, it hooks in. Anyway, I scraped the end of that to get that sheathing coating off of it. So basically I just took, that one's going to be number 1, white will be number 2, and then I'll use black for number 3, and then I'll do the same thing over here. So a beanie, these are beanies. They're a low voltage connector. And there's metal inside there, so when you open them up, there's metal in there that clamps around that wire. So you screw the wires together like this, and then you screw the beanie, just kind of wrap the beanie on it, and then squeeze it with a pair of pliers, and it crimps it. You can see how I crimped it right there and smashed it down. On some of these, if the wire's too big, you can take and basically, they come like an egg, like egg shaped, like that, but you can take your pliers and make them round to get them down over the top of that. All right, I'll be back in a minute. All right guys, I want to show you how I laid this out. I laid this out in quarters. So there's 36 coils on here, and letting build them out, so 1 through 9. So we start right here. This is the end, the factory end right here. So we go to the next one where this is, so it's going to be number 1. If you can see here, let me pull these out. I haven't glued it in yet. You can see right there where that line ends, it's all tied together. And then this is number 1 right here. Okay, so that's number 1. I label them out all the way through 9 and start over 1 through 9. Okay, these easy. It's way easier to do it this way. You just cut your lines, like, you know, there's multiple things have been documented how to do this. Okay, so these little things are called beanies. They're low voltage wire connectors. This wire that's coming in here is probably like the coil wire is probably a 20 gauge, 22 gauge, looks about the size of a phone wire, so probably 22 gauge, maybe 24 gauge, and this is 16 gauge wire that I'm running off of it. So I took number 1, first off, easier if you come back here to number 3. Okay, so 3 is right here. You're going to need the jumper from 3 goes to 9. Okay, so 9 jumps all the way to 3, 1 jumps to 4, 2 jumps to 5. So you find number 3, jump back 1 notch right here. So basically this wire that's right here, this wire, this black one is coming off the coil for 3, okay? So normally this would have went this way and coiled in and jumped over to 9. So I just came in here. So this wire would have been laying down in there flat. I cut it right here, past the second notch right here. Cut that, pull them up out of the way. Then you jump number 2, this wire would have been coming up and going over here to number 8. So I got over 1 notch, cut it. And then this next one, 9, you can't cut this one. You have to dig it down from underneath, down in there, and pull out the one that goes from 1 to 7, or 1 to 8, no, 1 to 7. You cut it down there, swing 7 up, and then all of these, now 9, 8, and 7, get tied together. It's a beanie. And then these, the other thing is these beans fold right down in this groove perfectly. I mean, they fit in there great, so I can do this, and then when I get the, start gluing it, it'll work out great. So anyway, it goes 1 through 9, so there's our first set, and then another 1 through 9, there's our second set, and then the same thing to 9, and then so it's 36, so I have 4 sets of 9. And then all of these are just pigtails. So I will then, after I get all this glued in and get it mounted on the board, I will mount this number 8 gauge into all those, tie them all together, and this is my plug, my high voltage plug that will plug into the line that comes up to the house. And I'm gonna have 2 of these, so I'll have actually 6 wires that come up to the house. Anyway, guys, that's how I did that. This, the pulley that goes on this, so basically this goes around the outside of that. The pulley, I had a hard time trying to figure out what I was going to do there, because I need it to be, 4 to 5 inches in size to get our rotations we need. So I had an old pulley. This is a 4.5 inch pulley, which means it's probably a 4-inch pulley. So basically I had some old solar mounts, hardware for the old solar mounts. I used that, just drilled 3 new holes, and it's right in the middle. It's perfect. So that's how we're going to build this system. Both of them will be built the same way. The next thing I'm going to do is wait for some parts to get here. We have our board cut. The hole in the middle is cut. But I got some bearings, some saddle bearings, pillow bearings coming in for this, and a 1/2 inch rod and some other stuff. So we're on a move. All right, this one is done. I'll give you a quick update of what exactly we did. Okay, so how these work is, again, there's 36 coils in here. When this drum runs around, so this will be hooked to this pulley, okay, and this will be hooked to the water wheel. The water wheel will make this spin, this drum spin around these coils, creating power. Okay, now the way these work is, as factory is, they're all tied together, and they're tied together by number 1, 2, and 3. So number 1 is actually tied to number 4. Then 4 is tied over to the next 9th one. Well, that would be over here somewhere, 5, 6, 8, or something like that. No, 7, whatever that math is. But so 1, it basically goes all the way around. Okay, and you can see right here, all of them come around, and then the last 3, these 7, 8, 9 here, they all go in and are basically wrapped together to basically ground them all out against each other, and that makes a 3-phase motor. Okay, so what I did was we divided this in 4s, so there's 9 coils, so it's 36, so divided by 4 is 9 coils per group. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this first 9 is actually going to be fed out of this, out of the factory connection. Okay, and then the next set, 1, 2, 3, 4, 5, 6, 7, 8, 9. The way this works, get that, stay over there. The way this works is, the easiest way to do this is to come over here to number 3. So basically you're going to use 1, 2, and 3. That's going to be your new lead here. See, we have these wires right here. That's our new lead. Here, here, and here. And they're tied, so this red is tied to number 1. The white is tied to 2 and the black is tied to 3, and that's uniform on the whole thing. Okay, so number 1, well, let's start at number 3 actually. Number 3 wire, this black wire, this used to come up and go around this post right here and head that way and connect to number 9. Okay, and then from 9 it went 1, 2, 3 and connected to 5. And basically loops all the way through. 2 does the same thing, but 2 would be connected to 5 or to 4. No, 2 would be connected to 5. And then 1 is to 4. So anyway, so on number 3, the wire comes up, this wire right here came up, it went around that loop and went over here to 9. So I went on the next little notch over, this one, and cut the number 3 wire, the wire that fed number 3. I cut that right there on that loop. And then on the next one for number 2, I went to the next pin, found it, traced it out, cut it there. And then the one for number 1 is actually going to be over here on 7. Yeah, 7. So I cut that over here, right here. On the next one over, I cut on the next other side of the post. So then that makes all 3 of these are now dead-ended. So you twist them together. So the last 3, so 9, 8, and 7, you take the ends there and you twist them together. So that is one little motor. Now these ones, so the red's on there, and like I said, we use these beanies. They worked out great. They will handle quite a bit of power. So number 1 is now going 1, 4, and 7. So that's the loop, the coils that are tied into that number 1 circuit. And this is 3-phase. So I guess that'd be phase number 1. Then phase number 2 goes 2, 5, 8. And then number 3 phase goes 3, 6, 9. And then these last 3 of the set of 9. So 7, 8, 9, there again, these are all pulled up, twisted together, dead-ended, put in a beanie, and then you start over with 1, 2, and 3. This is really easy to do it this way, guys. And to do the pigtails is way, way easier. Now this is, so the wire on the coils is probably 24 gauge, maybe 20 gauge wire. It's about the size of a phone wire. No, it's a little bit bigger than a phone wire, I think. It's about 20 gauge probably. Well, this is 16 gauge, and then this is 8 gauge. So I bring all the reds up and tied them in to the red wire here. Then all the whites came up, tied them into the white wire. We're going to call that white wire. Then all the blacks came up and tied into the blacks. That goes over and plugs into this. This is what I'm going to use my plug system. So basically, this is how it's going to get plugged in to go up and feed the wires going into up to the house. Okay, so that's how this works. Obviously, this gets flipped over on the board when it gets mounted, and then this rides on the other side, the flat side. So I got a little more glue to put on here. I ran out of glue, so I got to get more glue. But you put more glue on here, and these will be good to go. We'll have a test here shortly, hopefully. One thing I didn't mention was testing these. Once you're done, you take these leads, each one of these leads, and you can check for ohmage to make sure they're not a direct short in the system you've made. Each one of these groups, for me, each one of these groups was about 2.5 ohms. And when you put them all together on this, it's going to take all that ohmage and just basically drop it down to quite a bit. It's like 0.8 or something after you tie them all together. But each one of these, there's no shorts on them. They're about 2.5 ohms each. And then just tying all the wires together and checking them. Then they dropped it down to about 0.8 or 0.9, something like that. But that's just done with an ohm meter, and there's a lot of videos in there that show how to do that on YouTube. Anyway, guys, we'll see if we can get this mounted to a board and do some voltage checking. All right, guys, so I built this mount. It's basically 2 solid pieces of wood. Basically makes 1.25 inches. I'd like to make this in metal later, but anyway, I built this. It's not easy to do. If you guys are going to do this, I suggest you get the washing machine spindle and everything, because this is a real pain in the butt. So I got 2 bearings on each side of this board to get this shaft straight, and it's in the middle of this, as close as I can get it. And then on this drum, I put a 1/4 inch metal on it, bolt that on, bolted the pulley onto it, put spacers back there. So as we put this on, So to put that on there like that, I give you a spin and show you how, you know, if you compare it to that arm of the radial arm saw, they're pretty straight. So, but it goes on here, it still seems to rub a little bit. So I don't know what the deal is here. Should spin a lot freer than that. And I have two of these. I tried both. They're both the same. And right now it looks like the bottom down here on the, you look at the bottom down here, this gap. Looks like it's a little bit more here than it is up here, so not quite there, I guess. Okay, another trick, you guys, when you're sizing this up, put tape around the outside of this to give you a little bit of a buffer. It can take much on electrical tape, maybe 2.5, 3 winds. And when you drill this board here, drill it like with a 1/2 inch. These are 1/4 inch rods, all thread. So drill these in here like 1/2 inch so you have room to play. And also these ones in here on this metal plate. Drill this like 1/2 inch and use 1/4 inch. So that way you can have a little bit of play room on everything. All right, well, be right back. So as it would turn out, both these drums I bought off eBay, and it's actually bent right here. That's a mark that actually came with that mark, and that's exactly where this is bent in a little bit. I mean, just not much. I mean, there's such a fraction of what this, you know, of what this needs to be, but it's now spinning a lot easier. Basically, that piece came out where it was cracked, where it was bent. It finally cracked from just catching on stuff. So I took that piece out, and now it's still catching a little bit. But that would definitely work on a water wheel. But now I got one of these. It's not in there, so I'm gonna probably have to steal it out of that one. Maybe. We'll see. All right, so we're getting ready to turn the stator on. There's a washing machine stator we built. Remember, this is the one that has the dented stator, the drum on it. It was dented from the guys I got it from eBay. It's just a little dent, so it does make noise. But I got to turn. I changed the gear ratio. I think it was like 75 or 80 to 1. So every time that wheel turned one time, this gear here, that pulley there would spin 80 to 1. But now it's set at 45-ish, 48, something like that to 1. So every time the wheel spins one time, we can watch that by that seam right there that goes across. So every time that seam hits the bottom of that 4x6 and goes around, we know that's one time. So anyway, let's go put some water on it. So I'm just going to throw this pipe into the trough. Set you down here for a minute. Run you back down. I have to start that wheel spinning, and sometimes it starts blowing out the back side. Like that. There's our noisy stator from the dented drum. And I know it was dented when I got it because there was already a Sharpie mark. Excuse me. There was already a Sharpie mark on the drum where it was bad. So right now, we're going to go 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010, 1011. So 11 seconds for that to make one rotation. So if you took 10 to make it easy, that's 12. 12 times 45 is roughly our RPMs on that motor. Let's run up to the house, see what we got. Actually just did the math. That drum, the stator's moving about 240 rotations per minute, roughly. because you see it's speeding up and slowing down. And there's a lot of torque on that wheel. Let's go see what we got at the shop. Okay, I changed the gear ratio again. Now we're at 17 to 1. Before it wasn't moving fast enough to get the charge controller to activate. So we're 17 to 1. So every time that water wheel goes around one time, the drum on the stator goes around 17. So we're at about 150 rotations per minute is all on that stator. We're at the shop. Well, I'm just feeding this up on a 12.3 temp because I've got some 8.3 or 8 conductor to run up here, 8 gauge rather. But I just haven't pulled it through the pipe because I want to make sure this works right before I spend the energy to do that. Anyway, run up to the house. Alright, in conclusion, right now I have this 3-way going just to the water wheel. And we lost voltage, we lost 15 volts, changing the gear ratio so the water wheel is running better. But the voltage dropped from 48 and 50 to 35. For these activate, I think I need 75 volts. I turn it down to the solar, which is, there's no sun out today. I'm at 98 volts on both of them. Activation 85 volts, and I wasn't getting any output at all out of the water wheel. I was getting like half of an amp before. Right now I bet I'm not getting diddly squat. So in conclusion, putting those stators at groups of 9 1/4 I think is not I think it's too much. I think it needs to be 12s, 3 sets of 12 instead of 4 of 9. I'll show you what I'm talking about. What I'm getting out of that's 0.31 of an amp at 48 volts or 38 volts. So it's not diddly squat because these are putting out, I think it was 38 volts or 35 volts or whatever it was. So it's not even putting out a third of an amp. So let's go take a look. Okay, so remember we broke this down into 4 sets of 9 coils. I think you need to do 3 sets of 12 coils on your breakdown at the most for that kind of RPMs. We're only getting about 150 RPMs out of that water wheel and churning that. But you got to remember we're also rubbing on the stator because of that dented drum that I got. And I don't know how you can fix that dented drum. I have 2 of them actually. They're both dented. I wouldn't buy jack squat off eBay anymore. Find a used sewing machine and wash machine, take it apart, save the rod that comes out of the. I wouldn't do this again, guys. I would definitely start over with a used front load washing machine. Okay, guys. So in closing, I would not do this again from scratch. I would find a used washing machine that has a clean running stator with no noise, and go from there and basically cut out the plastic shell and use the shaft that's already in it. And I would not build this from scratch again. This is a major pain in the butt. It's hard to do to build this mount. Rewiring the stator's piece of cake. We wired this one, like I said, 4 groups of 9. I would probably redo it to maybe 3 groups of 12 next time to get our voltages up, only because this water wheel is not spinning this fast enough with the drag that's on here. And on this, guys, I bought this on eBay. I bought 2 of them, actually, and both of these are bent. Both these rotors are bent. It came, that mark was already on here when I bought it, not knowing. I wrote this on there, but that was already on there, not knowing what that meant. So basically, when I first put it on here, it was just, I had to take 2 hands on the outside to turn it. And it should spin, pretty free like that. And so anyway, in building this, a lot of things I've learned. When I built it the first time, one of the dang magnets in it broke, and I popped it out. And the other one right next to it was high, where this dent is right here. And that's a minute dent. Anyway, I took a grinder and grind down the magnet a little bit to make it smoother. But it's still, and you can look at this. If we put that up like right there, so you're looking at the red line here. And look at this rib right here. You can see as I spin it, it's pretty damn close. You can see the dent in it. But I mean, it's minute. But the clearance between these coils and the magnets inside here, it is minute. So the smallest little dent, smallest little this thing not being completely on center. And the reason this is off balance is because I took this magnet out. But yeah, just putting this on there, you know, it's pretty damn straight. But you put it on these magnets, and it's just hard to turn, which is slowing down the water wheel. I mean, you know, that should go like that. It should keep spinning a little bit. Anyway, that noise, it's catching. So, yeah, I would not do this again. I would buy a washing machine and keep it all, this mount part, all part of it. I would not do this again, which is what I'm going to end up doing. I'm going to scrap this and start over, because we should get some power out of this. What we got was ridiculous. And for me to restart this and drill and do all that, no, I'm not. I'm just going to start fresh and do it the right way. Or the other way, not the right way necessarily. But anyway, guys, thanks for watching. Sorry we didn't get better results for you. Stay tuned. We'll try it again.